Hi, welcome back. Here we have October 2021. First part is solve 3 by x greater than 4. 3 by x greater than 4. Whenever we have a fraction in an inequality, what we'll do is we'll multiply the numerator and denominator with the denominator. So x multiplied by x, 3 multiplied by x. So we multiply the numerator and denominator with the denominator. So 3 multiplied by x is 3x. X into x is x square is greater than 4. When we cross multiply this, we will get 3x is greater than 4x square. 3x goes to the other side, it becomes 4x square minus 3x and left hand side. It's always preferable to make the variables to bring the variables on the left hand side. So what I'm going to do is I'm just swapping the right hand side and left hand side. But when we do the swapping, when we change the sides, the inequality will change. The complete right hand side is going to be the left hand side now, 4x square minus 3x. And the left hand side will be my right hand side, that is 0. Inequality greater than will become less than. I can see that I have a common x here. Let's factorize it. So x into 4x minus 3 is less than 0. We need to find out the critical values here. Critical value is nothing but the x-intercept. So equate to 0. X into 4x minus 3, when you equate it to 0, you will get x is equals to 0 and x is equals to 3 by 4. Sketch the graph. So when we sketch the graph here, 0 is over here and 3 by 4, let's take it over here. Now the coefficient of x square, we know it is positive 4. Positive 4 means it will be a U-shape. It will be a U-shaped parabola. And then the inequality here is less than. Less than means it will be the region below the x-axis. So this particular region is occupying what part of the x-axis? The part of the x-axis is 0, between 0 and 3 by 4. So the inequality which we will be getting is x is greater than 0 and x is less than 3 by 4. This will be your final answer for first part. Now, moving on to the second part here. Figure 1 shows a sketch of the curve C and the straight line L. The infinite region R shown shaded in figure 1 lies in quadrant 2 and 3 and is bounded by the curve and the line only. Given that the line has a gradient of 3, the equation of C is y is equal to 2x square minus 50. C and L, both of them intersect on the negative x-axis. Use inequalities to define the region R. We need to use the inequality to define the region R here. So equation of the curve is already given, that is y is equal to 2x square minus 50. Equation of the line we need to find out. We know the equation of a line is always in the form of y is equal to mx plus c. Now the gradient of the line is given as 3, so this will become y is equals to 3x plus c. We need to find out the y-intercept now. In order to find out the y-intercept, if I have a point on the line, if I can find out a point on the line, I can substitute its x and y coordinate and get the y-intercept. So when I closely look into this line, I can see a point on the line that is actually the x-intercept of the curve. So if I find out the x-intercept of the curve, I'll be getting a point on the line, this particular point, which is a point of intersection. How can I find out the x-intercept? By substituting for y as 0. 0 is equal to 2x square minus 50. Minus 50 goes to the other side, becomes positive 50 is equal to 2x square. So x square will be 50 divided by 2, that is 25. X will be plus or minus square root of 25, that is plus or minus 5. So this is minus 5 and this one over here will be 5. So I have the point on this line, that is, this is on the x-axis, so this point will be minus 5, 0. minus 5 comma 0. Substitute this here. Instead of y 0, 3 into x is minus 5 plus c. So 3 into minus 5 is minus 15 plus c. Therefore, c is minus 15 goes to the other side. You will get c as 15. Your equation of this line will be y is equals to 3x plus 15. This is the equation of the line. Now this equation is y is equals to 3x plus 15. The region that we have here, I can see that it is above the line y is equals to 3x plus 5. If it is above the line, then the inequality is going to be y is greater than 3x plus 15. Since it is a solid line, the line L is having a solid line, we can say y is greater than or equal to 3x plus 15. Now, 2x square minus 50, you can see that 2x square minus 50, that is the curve. This is above the x-axis. The region that we are considering is above the x-axis. So above the x-axis means we know it will be greater than. So this will become y is greater than 2x square minus 50, and it will be greater than or equal to. The reason is that the curve is also having a solid line, not a dotted line. So the region is y is greater than or equal to 3x plus 15 and y is greater than or equal to 2x square minus 50. The problem is that y is greater than or equal to 2x square minus 50 means the region above the x-axis. The region above the x-axis means not only this region, but also this also considers. So, but we don't have this region as a shaded region. So we need to consider only the left-hand side of the, y-axis. Left-hand side of the y-axis means, we know y-axis is basically x is equals to 0. The equation of y-axis, x is equals to 0, and we are considering only the region towards left of it. So we can say x is less than or equal to 0 as well. X is less than, we cannot say less than or equal to, we can say only less than 0. X is less than 0 because we are considering the region towards the left hand side. So I hope you have understood this. Thank you for watching.